Hello again, YouTube. So today we're going to look at something that I haven't really spoken of or touched in a while, probably about 2 years, and that is my solar panel setup. So if you know, I had a system of these three solar panels, this 15 watt one, the 5 watt one right there, the monocrystalline one, and that 1.5 watt amorphous panel. So I had a setup with these solar panels, and they would connect to this 12 amp hour battery, and I had a charge controller and some other stuff here, and I was able to power some small electronics. I charged a phone off of it, I ran a fan, stuff like that. Uh, well, uh, about a year and a half ago, 2 years ago, uh, all this stuff kind of got dismantled while I was going to college. So I haven't really had that much time to play with it. It's just been sitting in this garage in storage. Alright, so first of all, we have this solar panel. It's really kind of dusty. It's been sitting in storage again for 2 years, basically. Uh, this solar panel and these two, they're not that bad. They were never sitting outside. This one was outside. Uh, so what I'm gonna do is I'm gonna take this outside. I think it would be interesting to see which kind of voltage that this makes while it's covered in dirt. And then what I can do is I'm gonna clean it off with the Lysol wipes, and then we can measure the voltage again. And by doing this, we could see if cleaning it off actually has any noticeable increase in voltage. It's not that scientific of a test, but whatever. Basically, we're like the Mars rovers that were on Mars. They had their solar panels. They got covered in dust, and they weren't able to produce as much power. Uh, it might be the same for this too, but it's an amorphous panel, so these are good in low light. But still. So also, yeah, we have this panel too. It barely produces anything, but it is lighting up that LED. I'll throw it in back in the system as well. So in here, yeah, let's see what we got here. So this is an 80 watt power inverter. I had this on a bright sunny day with all three of these panels connected up. I could power this just off of the solar panels. This is a very small system, so it's an 80 watt inverter. You could charge a laptop. Maybe I'll try charging this laptop. By the way, this is a laptop that had the broken hinge that got a bunch of views because the thumbnail was good on that video. But yeah, so here's the hub. It has this kind of, I forgot what the connector's called, but they go in here, and you could connect up to 8 solar panels, and you could have it output to your charge controller, which is, this is the one that I was using all that while ago. It's a 7 amp 100 watt max, so 100 watts. This system is 20 watts maximum, maybe. It's probably more like 15 watts, really, because it's none of these are in an optimal position. So this is well below its limit, which is good because I'm thinking about upgrading it. You can get a 100 watt solar panel for $100, which would massively increase the power of the system. It would basically be way more than all of these three combined, but I'll run them in parallel anyway, just to get even more. So yeah, this charge regulator should be good for a while. It is a really cheap one. As you can see, it has the battery goes in here, solar panel goes in here, the load goes out here. So it will regulate your charge and your load as well, so you don't drain the battery too much. You can see what I connected here was just an extension cord. Here's a cord right here. So what I would do is I would just plug this extension cord into here, and I would be able to run my loads off of here and have have several sockets to plug in different 12-volt loads, and I could have an extension. Well, I think this was kind of an okay idea. I don't like that it uses these 120-volt plugs. They could easily get confused with the 12-volt plug. So one thing that I want to do is make sure that this is a 12-volt plug. Also, another thing that is in need of looking at again is this battery connector. It's not the battery connector. This one goes from the output of this to the solar panel input. What I had was actually these two were basically facing opposite of each other. So we had a cord kind of like this that can go in between these two. So yeah, I'm either going to try to make a better one of these cables or just switch the system to Anderson power pole connectors, which is what I think I'm going to do. So I pulled out some parts that I'm going to use to upgrade the system. Right here we have these quick disconnect, they're power pole connectors. I have a whole bunch of them in here. They can go up to 45 amps. So that should be way more than enough for all this stuff. And what I want to do is replace a lot of these connectors with these. Maybe just I'll use these original connectors to go in here, and then out of here we use these ones. Also I have some fuses. These are pretty small fuses. I'm probably not going to use these on any single load on like the main thing, but like on like individual loads, I can use these. These go up to 6.3 amps, so again, that's probably more than this could all produce at once. Also, just another thing that I have here is a Raspberry Pi. It's kind of a weird thing to have in here, but what I want to do is I want to be able to power this from the solar panels and have it run 24/7. Maybe you could use it as a web server or mine bitcoins with it, with completely free electricity, which is what we want to do here. Here's a battery box. Yeah, same one that I had. This battery. Okay, this battery has been sitting around for a while, so the charge on it might not be that good, but we'll obviously have to test it. What we're going to do with this battery is we have these connectors. Originally what I did is I just had alligator clips going to these, but if I get these connectors, it could probably make a more solid connection like this. So I'm going to probably replace it with these, maybe put the fuse in here or something like that, and it could look much better. And what I could do is I could get a couple more of these. I'm not really thinking about moving to deep cycle big batteries just yet, but what I could do is I could get maybe a couple more of these 12 amp hour batteries. Maybe I'll find them somewhere. And then we could have like 24 amp hours. In this battery box alone, I could probably fit 3 of these. If I put them like this, yeah, I could probably get just about 24 amp hours, maybe a couple little ones I could put in there. But yeah, we could probably have like 40 amp hours if I get some more batteries. Also, just to monitor the system, while this charge regulator is well within the range of its current, it doesn't have a display or anything on it. It just has high voltage charging low voltage, which what is high voltage, low voltage? That doesn't give me an exact reading. So what I have right here is a voltage, analog voltage meter. I've had this for a while. It's been sitting around for a while, just like everything else. So I will be more than happy to put all this stuff to use and maybe do something with it. And again, I could probably put a fuse in here, just because I have so many. Here's some other stuff. I have this USB cable that I could use to power the Raspberry Pi. Another thing, the Raspberry Pi uses 5 volts. To get 5 volts, I might be able to just use this inverter, and it has a USB port right there. But obviously the problem with that is that this inverter would be running, converting it to 120 volts whether I like it or not. Which, while this is convenient if I want 120 volts, like I said, this system can not produce that constantly. So what I'm going to do is I'm going to get I have some little buck converters, and I'm just going to splice this cable with a buck converter and run it probably through one of these power pole connectors straight to the battery. And I could probably have several USB devices on here. The USB specification for the standard of USB connectors is 5 volts and 2 amps. So I could probably power a few things off here. I have 2 Raspberry Pis, so 4 amps maybe. I also have some old phones and tablets, which I could probably charge off of here as well. And that's what I think I want to do with this system. Also right here I have this old laptop, which I was thinking about trying to power with the system. But if you see the connectors right here, this is a power supply for it, and it's like 19 volts. Yes, so the problem with this power supply for this Dell computer is 19.5 volts. And that's true for all computers, basically. All computers require around 20 volts, 19 volts in order to turn on. Well, for laptops at least. Except for, oddly, the new MacBooks. You could charge those with USB-C on 5 volts. But that's besides the point. With these just regular PCs, you need 19.5 volts, 20 volts. This system, while it can produce that voltage, it's going to go down to 12 volts is what it can really charge. So in order to get that high voltage, I'm going to need a boost converter, which I don't have, but I want to see if I could try to make one. And that will prove very useful for charging laptops. Like I said, you could charge them with the inverter, but you're losing efficiency because you're converting from DC to AC to DC, when it would be much more efficient just use a DC to DC converter, which is what we're going to try to do eventually. Other than that, I think we've gone over pretty much everything that I'm going to use here. Also, I have this 12 gauge wire. It's a silicone coated wire, and I can use this for connecting the batteries and for some other stuff. Maybe coming from the solar panels, I could use this thicker wire as well. Obviously, this charge controller uses really thin wire, but just to open up the upgrade for the system. Also, another thing I want to do is maybe I could try to make my own charge controller. That might be a good idea as well. This is it's just a simple PWM charge controller. What you really want is the MPPT charge controllers. I don't know how either of them really work. I kind of know what PWM is, basically. So maybe I'll try to make one as well. So what I think we're going to do now is we're just going to work on this solar panel. Alright, so we are back again, and here we have the solar panel, and we're testing it. It is unfortunately rather overcast right now. Well, I guess the sun is starting to peek out a little bit. But what we have right here is we're producing around 21.2 volts, which is probably about what you would expect from the solar panel. But as you can see, it's kind of covered in dust right now. This angle kind of gets it especially well. So I'm going to clean it off, and let's see if we could get more power from this. Or at the very least, we'll just have a cleaner solar panel. Yeah, this is not... Yeah, this is really bad right here. I have not cleaned the solar panel off in a very long time. So I think we just about got it. and we're producing 21.2 volts, so probably did not affect the voltage at all. Maybe it would affect it if there was more light or something like that. So I think while we're at it, I'm just going to clean out the rest of this. You can see just the dirt got really on here. This frame was actually buried in the sand a little bit. And you can see some of it's kind of corroded, actually. This bar, even though it's a galvanized bar, this is all either galvanized metal, this metal is plated and painted, and this is aluminum. Even then, by burying this in the dirt, it's still got kind of corroded. So here's the cable. The cable, it kind of looks okay, but this part was the part that was outside, because obviously this part was shoved in the window to feed the power in. So what I'm going to try to do more is try to protect the cable. This is always getting hit with UV light, which is not especially good for the plastic on the cables. I don't think so. This is my kind of cheesy frame that I made out of just whatever. It's not the proper angle or direction. I think this direction is south. I'm not sure. But I think it works out well after a few years of it being built. It's still kind of stable. All right, so what I have here is this charge controller and this fans, which should be a pretty light load. These are 12 volt fans, just 3 of them. These consume about 0.1 amps each, as it says here. So 0.3 amps. I should be able to power all 3 of these, even though it's overcast and not in the most ideal conditions. So we could just unplug this, plug this into the solar panel, and which gives us this connector, which I desperately need to replace. I do not do this with the normal 120 volt outlet. This is a 12 volt outlet. I believe if I wired this in the way that I think that I did, this is positive and this is negative, which is important for these computer fans. They only spin in one direction. This is the plug for these fans. It's a, let's turn this off, I don't want it to grind the dirt. It's a 9 volt plug. So I might have to switch these actually, because this might be reversed. Yeah, I think it is. Because this is supposed to be able to be powered by a 9 volt battery. And this is not a 9 volt battery, it's a connector, so it should be reversed. So if my hypothesis is correct, this should turn on. Okay, maybe not. Okay, so here we are again. You can see that the fans are spinning now. Now it's with the sun at a much more favorable angle. The clouds have finally cleared up enough so we have direct sunlight. And it is going to all 3 of these solar panels. Even still, this solar panel barely produces anything. You can see, shade this, block it off, it doesn't do anything. This one produces some. You can see, if you hear closely, the fans will spin down. So yeah, so this solar panel is generating quite a bit of the power, but really most of it's coming from this one. See, if I stand in front of this, this will... Yeah, it goes much slower. So it does appear with direct sunlight, we are getting an appreciable amount of power, which is good. You can see that the stand I made for this is actually a music stand, which I got for originally practicing guitar, which I have since stopped practicing guitar. I'm practicing this now. So this makes a good solar panel stand, if anything else. I took out the charge controller just because we're not charging anything. We could actually try to charge this battery, which probably needs to be charged a little bit. And yeah, so with this direct sunlight, we are producing an appreciable amount of power. But the real question is now, how much time in the day can we get this direct amount of sunlight? And I don't know that. I would actually have to measure that by having these solar panels out here, maybe within an Arduino and a voltmeter, just logging the voltage we're getting off of here or something throughout the day. So, and usually it ends up being like some kind of a bell curve. So what we could do with that is find out how much power every day each of these solar panels really does make. Also, it depends on the current and stuff like that. Maybe just by measuring how much charge the battery gets, we could determine what these solar panels are actually making for me and what my energy budget is for loads I want to put on these 24/7, which is ultimately what I want to do. You can see the sun, maybe it's going down a little bit, but this is making quite a bit of a breeze. It's an insignificant load. It's 0.3 amps for all three of these combined, so I mean, you can definitely feel it, but it's not that much power. My goal for this was to power a PC, but if I could barely power the fans, maybe that's a bit of a problem. Alright, so what I think we're going to do now is put this charge controller back in the system and see if we could actually charge a battery. So rather than powering the fans, we could charge this battery, and positive and negative, and you could plug in the battery, would go right here. Funny how as I'm doing this, the sun is going back into the shade. Oh no, the battery's a low voltage. Well, what we have here is we have our solar panels, which could hopefully make up for that. So let's measure the voltage with this multimeter. And our starting voltage is, let's see right here, 11.49. So this battery has a low voltage, which is expected. It's been sitting around, not charging at all. So let's see if we could put some charge back into this battery. So right now the battery, how we have it here is it's charging off of it's 12.99, 13.7 volts, which is a fully charged battery should give that voltage disconnected. That's how much it should be. Actually, it says on the battery right here. Charging voltage 14 volts. Well, it's my fault for buying a cheap phone with a cheap camera, but the charging voltage for this battery is 14.5 to 14.9 volts, which is rather high. Normally for flooded lead acid batteries, they have a lower voltage that they charge at, but this it's a sealed lead acid battery, which typically these just have a higher charging voltage. So what's happening right now is these solar panels, they're in semi-direct sunlight, and they're making about 20 volts. Just about. Maybe 22 or whatever, all combined into here to give us about several amps of current, and that's going into the battery. So what we do is let's actually try to measure the current that we're getting into this. So 10 amps, the unfused current, which if you're working with multimeters, they have a current limit of 10 amps for most of them. We're not dreaming of exceeding that right now. So how you measure current is you have to wire it in series. So let's see how much current we're driving into the battery. So the negative goes to the positive, goes to the negative. And let's measure current. Alright, so we can see that we are charging at about 130 milliamps. It could go up to 200 milliamps at most. It says that it's negative. I don't know what that means. Does that mean the battery's draining power into the solar panels? I don't think so, because the charge controller should be regulating that. If not, we need diodes. Maybe it's because I wired this like this, but normally the negative goes to positive, positive goes to negative if you're wiring in series. At least that's how it's supposed to go. So we're going to charge this battery. We started at around 11 volts. We're going to check back again in a while and see if it's actually charged. Okay, so it has been a few, I'd say 20-30 minutes, and it looks like the sun is kind of starting to go down. And that is evidenced by the fact that we are getting about 52, 51 milliamps, which is rather low. So it looks like it's coming to an end. I'm going to put some of this stuff away and set it up later. So let's see how much our battery has charged. Alright, so here we are after charging it for about 30 minutes. With the entire solar panel system charging this battery. We started off at about 11.4 volts. We probably haven't charged that much. So we have 11.81 volts, which is actually pretty good considering, again, it was overcast. There's only a couple of panels for only a few minutes, kind of late in the evening. So yeah, I think that with this system, we could probably get some usable power out of it, and maybe we could even power a computer or something. With what we have here, we could definitely charge this battery every single day, up to full power. I don't know how long this battery could run something. Probably for a couple hours if it's a few amps. Like with a Raspberry Pi computer, which draws 5 volts at 2 amps. This is 12 volts, 12 amp hours. So if we do a little bit of math, then that means that, so 12 amps. So this could power something that draws 12 volts for 12 hours. Screw off. Alright, so with this battery, we could, it's 12 volts, 12 amp hours, which means if something draws 1 amp at 12 volts, it would last 12 hours. Since 5 volts is about half of 12 roughly, even though it's not. And a Raspberry Pi computer would draw about 2 amps, so if we do rough math, we're gonna get maybe about 14 hours running a 2 amp load at 5 volts, which is charging a phone, running a Raspberry Pi, for 14 hours off of this battery with a full charge. Which I think is pretty good. It's not 24 hours, but if I get 2 of these batteries, then that's easily all day running loads. Though if I have 2 of these batteries, I probably need to upgrade the system as a whole. But overall, I think that's kind of a good way to try to revitalize this system and see more videos about it to come.